Hello everyone. Previously we had discussed on the LCA algorithm, right? So using the binary lifting as well as for this one RMQ, arrange minimum queries, right? So today we'll be discussing on the topic validate binary search tree algo, right? So here let's get into the definition part first. So what does the definition part say here? A binary search tree, also known as BST, is a binary tree in which for every node all the nodes in its left subtree have the smaller values, right? A binary search tree, BST, is a binary tree in which for every node all the nodes in its left subtree have smaller values and all the nodes in its right subtree have the larger values, right? A binary search tree is a binary tree in which for every node all the nodes in its left subtree have smaller values and all the nodes in its right subtree have the larger values, right? So we have to validate binary search tree algorithm that checks whether a given binary search tree satisfy the this one binary search tree properties or not. Again, so here for every node all the node in its left subtree have to be smaller values and all the nodes in its right subtree have the larger values. Suppose let's consider this one. I'll just show you just for the sake of example. So a simple one, very simple one basically, right? So let me consider 6 here. So the left subtree has to be what it says here, all the nodes in its left subtree have smaller values. Suppose let's consider here 4 here. This is fine, smaller values, and all nodes in its this one right subtree have the larger values, right? So let me consider 8 here, right? So same thing goes with here as well, right? So same thing goes with here for this one as well. If you consider for this one 4, so this one has to be let me consider 2 here and let me consider 5 over here, right? So this is also binary search tree. Basically this is binary search tree, right? So our left value has to be smaller and the right value has to be greater. So for this one we have 4 basically. So here we have 2 and here we have 5 basically, right? So the left value less, right value greater. So this is said to be the binary tree. This is the criteria basically. So what we have to do, what does the algorithm do? Basically we have to validate the binary search tree basically, which checks whether a given binary tree satisfy the binary search tree properties or not. Now let's get into the explanation part. So the first thing here would be to validate a BST we can use recursion, right? So to validate the binary search tree we can use recursion. One thing again, to validate the binary search tree we can use recursion. The idea is to ensure that each node's value lies within the valid range. Again, to validate the binary search tree, what we can just make use of the recursion here. The idea, what is the idea? The idea is to just ensure that each node's value lies within the valid range, right? For the root node, the first node or the root node that we consider here, the range has to be from the negative infinity to positive infinity. This is fine, simple. The next point here, for the left child I showed you, right, whose value has to be lesser than the root, the main value, right? So for the left child the range becomes minimum value and the parent value, right? Because it is lesser, it has to be lesser, the left node. Right node, the value has to be greater than the root node, right? So for the right child the range becomes parent value comma maximum value, right? So this is fine, very simple. If every node satisfies its range condition, then the tree is said to be valid binary search tree, right? So let's implement or articulate the same thing in the form of code now, right? So let's come to the this one, what do we call, let's get into the coding part or the algorithm part, right? So first let's do one thing, let's define the class for the tree node. So I'll just give here class tree node, this one, right? So this is fine, man. Now within the class let me go with def, so I'll just go with init. So this is fine. So this one self comma value, right? So this is fine, man. Now within this function let's go with the value of the node left child and the right child. First let's go with the value of the node. So this one will be val. So this is fine. The next one would be we have to consider the left child as well as the right child. So this one will be self dot left. So let me assign this one to the none, right? So sorry, this has to be in the next line, man. This is fine. The next one would be right child. So this one is self dot right. So this one, let me go with a none. This is fine. Yep. Now let's do one thing. We are done defining the class for the tree node, right? So now let's write the function to validate the binary search tree. Let's write this one. This is simple. Basically, I'll just go with def here. The function name is validate. We are validating binary search tree, right? So I'll just go with the BST here. Is validate BST. So now let me go with the parameters node as well as let's set the minimum value to the float of, so this one has to be within the negative infinity to the positive infinity, right? So this one, let me give here minus this one negative infinity. This is fine. Also max value, so this one I'll just go with max value equals float of this one, what do we call, infinity, float of this one, positive infinity. This is fine. Yep. Now let's do one thing. First thing here, if node is none, right? So I'll just write here on this way. If node is none, then let's return true, meaning an empty node is always valid, right? So this one I'll just give here return true. This is fine. Next part here would be, we have to check if the current node violates the binary search tree properties or not. So this one is if not, I'll just go with the min value less than node dot val. So this is fine, less than max value, right? So this is fine. Then what we'll do, let's return false. I'll just go with return false, right? So this is fine, man. Next step would be, we have to recursively check left and right subtree, right? So I'll just go with return. So I'll just go with is validate binary search tree. This one we are going with a recursion, right? We are recursively checking left and right subtree. So this one I'll just go with a node dot left. This is fine, minimum value, and also we have to go with the value of the node, nothing but here node dot val, right? So this is fine, man, right? So this one will be, and yep, let me go with this one. Let me copy this one entirely. So, or I don't know, let me copy this one entirely for now. This one, yep, let me copy this one. Anyways, so this one is validate binary search tree node dot so this one will be right. So this one will be min val. Instead of min val, I'll just go with a node dot val, right? So this one I'll just go with node this one dot val. So finally we'll be going with a max value, right? So this one will be max underscore value, right? So why this is throwing error here? Oh, this one I have considered min value, so I'll just everywhere I have given value itself. So this one, let me make this one val itself, because so for the max value we have considered val, right? So everywhere this is fine, man. Yep, now we are done with this part, right? So we are done with this part. Yep, this is it. Basically we are making use of the recursion, right? So code becomes very simple, man. So this is it, right? So we have successfully written the algorithm to validate the binary search tree, right? So we are done with this part. How to check? Let's make use of, let's build a tree. Let's create a sample tree first. Let's consider the example usage, and then let's check the output, right? Now let's consider this one, some random one. So I'll just go with this one, 5. Start with 5 itself. So let me go with 5. So binary search tree, right? So let me consider 3 here. This one let me consider 7 here. This is fine. Now for this one, let me consider 2. This has to, left has to be small and right has to be greater than this one, greater than the root value, right? Parent 1. For this one, this is the parent, basically 3. So 3. So right one has to be greater. Let me give 4. This is fine, right? So this tree will be considering for the example usage, right? So this is the sample tree we are considering for the example usage, right? So I'll just go with here root equals tree node of 5. This is fine. Again root dot left. So this one tree node of 3, The third one is root dot right. So this one tree node of 7. The fourth one is root dot left. So this one is tree node of basically 2, right? So the final one is root dot left dot right. This one is tree node of 4. So this one will be tree node of 4. We have to check if the tree is the binary search tree or not. So this one will be result equals is I'll just go with validate binary search tree. So this one is of root. So this one I'll just go with a print here. So I'll just give here within the strings is the tree a valid binary search tree. Binary search tree, and let me pass here a result. Basically we have considered result itself, right? Yeah, result. We have to start from the root, so I have passed the root here after passing the function. This is fine. Now for this particular example we have to get the output true basically, right? So we have considered, see here 5, the left one is 3, this one, and the right side this is greater and this has to be 7, and this one has to be this is 2 and this is 4. But basically this is the valid binary search tree, right? In this case we are passing the result, so we have to get the output in the form of boolean, right? So we are just passing the result. So here we have to get is the tree a valid binary search tree, and the result we are displaying. So the result has to be here, yes, here in this case, right? So let's check the same thing. So before running the code, let me do one thing. So I have already explained this one, right? Step by step, no worries. So let me run the code, man. So I'll just come here. So let me copy the entire this one. What do we call Python code? So I'll just give here Control J, clear screen. So this one will be Python. Yeah. If I run this one, what is the output that we need to get? Yes, right? True basically. Sorry. This is Python. True we have to get, right? So boolean value 2. Sorry. So I said yes. So we have to get the output yes in the sense it's true itself. Don't get confused, right? So is the tree a valid binary search tree? Yes, it is. We have to get the boolean value true. We are getting the desired output, right? Suppose if we consider, so 5, 3, 7 here I have given. Suppose if we go with 5, 6, 7. 5, 6, 7. 6 is greater here, right? In that case we have to get the output no. Let's check the same here. So I'll just give let me run this one here itself now. So yeah, false we are getting. No, again yes or no. I am getting confused with yes or no and true and false. So this is by this one, right? Boolean value false, right? So we are getting the correct output. 6 is greater than 5. Left subtree has to be this one. Left child has to be, the value of the left child has to be greater than the smaller than the root value, right? So here it is greater. 5, 6, 7. 6 is greater than 5, right? So we are getting the output false here, right? So let me give a screen here again. Let me change this one because I'll be uploading the same code on my GitHub as well. So let me give here 3, right? So this is fine. Right? So we are done with the what do we call? We are done with the validated binary search tree algorithm. So this is it for the validated binary search tree algorithm. So let me summarize whatever we have learned so far. So the first point here would be a binary search tree has the property left less than root. This one basically left has to be less than the root value and the right has to be greater, right? So this is fine. We know this one, right? Right child has to contain the greater value than the root, and the left this one child has to contain the what do we call the value has to be lesser, right? So this is fine than the root, right? A root value basically. So is valid binary search tree, whatever I have considered here, this function is validate binary search tree. So this one checks recursively if each node lies within the valid range or not. That's what we are doing here, right? So this is fine. The algorithm basically runs in big of n time. So we have discussed this one. The algorithm basically runs within big of n time, right? Visiting all the nodes exactly once, and recursion ensures that the constraints from all the ancestors are respected, not just the parent child. Again, recursion ensures that the constraints from all the ancestors are respected, not just the parent child, right? So this is fine, I believe. Now we are done with the this one, what do we call, balanced binary search, validate binary search tree algorithm, right? Again, I'm telling this one I'm telling from past 2 to 3 videos. I'll be uploading the code on the GitHub using Java as well. I practice on the Java mainly, so I'll be uploading this one. You can just check the Java one as well. So this is purely written, right? This is purely written and cleanly written, basically. Sorry, it's cleanly written, step by step. So the explanation is same for both, right? So whether it may be Java, programming language doesn't matter. The explanation is same. I mean, the approach is same. The code, Java has this one, what do we call, heavy syntax, right? So the syntax on the Java is heavy basically compared to the Python. Python is very easy, man. I'm not gonna lie. This one. It's very easy to write the code in Python, right? So that's what I wanted to say. This is fine. Now we are done with this part. Next, let's do one thing. Let's move on with a balanced binary search tree conversions algorithm, right? So for now, this is it. Thanks for watching, guys.